Hi friend, welcome to PLANTI.com. Today I am going to demonstrate salting in and salting out in biochemistry. Salting in, the term signifies that salt in, that means salt add. The solubility of protein at low ionic strength generally increases with increasing salt concentration. This process is known as salting in. That means in low ionic strength condition, the protein solubility is increases, and this condition is known as salting salting in. It occurs due to the binding of salt ions to the protein's ionizable groups, which decreases the interaction between oppositely charged groups on the protein's molecule. Water molecules then form solvation pair around this group. At first you see here protein, the blue part is protein and the grey part is H2O. Protein and H2O interact between. Then when you add salt, the protein become interact with salt ion. And then water molecule form a solvation pair around this group. Then protein add with salt ion. Then water molecule make a sphere on this group. Here make a sphere. Sphere means a round type sphere on this group, protein and salt group. Next, salting out. When salting out means salt out. When large amount of salt are added to a protein in solution, a precipitate forms. The process is referred to as salting out. That means in the next condition, after salting in, when you add more salt, then a protein in solution, a precipitate form, a precipitation occurs. This process called as salting out. But why precipitation occur? Because the cause of insolubility in this case is different from for isoelectric precipitation. Salting out is dependent on the hydrophobic nature of the surface of the protein. We know hydrophobic nature of the surface of the protein. We know in protein, in the interior part hydrophobic nature are present and the outer part hydrophilic region are present, but here you see surface of protein, hydrophobic nature of surface of the protein. That means some of case in protein hydrophobic region are in exterior side. That's why that's cause the salting out precipitation. Hydrophobic groups predominant in the interior of the protein. Here you see that hydrophobic groups predominant in case interior of protein, but some are located at the surface. In some condition it can be stay surface of the protein. Water is forced into contact with this group, and water always forced to contact this group, hydrophobic group. When salt are added to the system, water solvates the salt ions, and as salt concentration increases, water is removed from the around of protein, eventually exposing the hydrophobic groups. Hydrophobic groups on protein, one protein molecule can interact with those of another, resulting in aggregation and thus precipitation. That means at first protein interact with water, and next condition, when you put a salt, then protein become interact with salt, and water make a sphere. In the next condition, when you put more salt, then in the hydrophobic region of protein are exposed, and the water molecule interact this hydrophobic region. In this condition, protein become aggregate, and when protein become aggregate, the salt ions are sphere, and this protein are precipitate. This protein become precipitate because it is aggregated form with hydrophobic region. That's why salts are aggregate. Nextly, here you see that salt molecules, protein, hydrophobic region. Here blue part is salt molecules and the sky part is blue. Sky part is hydrophobic region and the orange part is protein. Here at first protein interact with hydrophobic region, then salt come, you add here salt here, add salt here, salting in condition, then protein become interact with salt. In next condition, protein interact with salt more, then when you more salt add, then due to hydrophobic region exposed, then protein become aggregate because water is present here and hydrophobic region is exposed, then protein want to aggregate and it is precipitate and salt in the outer side. This is the whole graph. Here salt concentration and solubility, and you need get a protein part. Okay, thank you for watching my video. I think this video going to helpful for you.